Welcome to the Deep Dive for Factory English, Episode 6. Today we are going to talk about an interesting topic, product models.
We really are. It's a fascinating one today.
It is. I mean, imagine watching this, highly profitable factory just suddenly stop.
Right, completely freeze up.
Exactly. The heavy machinery goes totally quiet. Thousands of dollars an hour are just bleeding out of the company's bottom line. Workers are standing around off the assembly line, and the facility is producing absolutely nothing.
Which sounds like a total disaster.
Yeah, but the craziest part, management actually planned for this to happen.
They did.
They scheduled this massive loss of revenue on purpose. So today we are exploring the chaotic, expensive, but entirely necessary world of product models.
Yeah, we are taking a highly focused text used in actual factory operations, and, we're breaking down the realities of how these models work. So for you, the listener, whether you are actively working on a production line, maybe managing a team, or, just prepping for a morning production meeting, our goal is to help you really master the core concepts.
And the vocabulary, right.
Exactly, that essential English workplace vocabulary that drives these huge decisions.
Okay, so before we turn to the mechanics of this, let's lay out the entire factory brief.
Right.
That way you, the listener, can just hear the natural flow of the English first.
Sounds good.
So let's do a rapid briefing. Could you give us the high-level summary of what this document actually covers, and then we will read through it?
Sure. So fundamentally, the brief explains what a product model is.
Okay.
It details how swapping between different models forces a factory to physically tear down and reset its heavy machinery. And then it answers the big underlying business question, which is, why do companies put up with that massive loss of production time?
Right. Why suffer through it? Okay. So I will take the product side of the text, and you take the business side. Ready?
Ready, let's do it.
A model refers to one variation of a product that has its own set of features or design. Different models of the same product often share the same basic function, but they vary in size, features, style, or performance. For example, think about cars. A car company may have one vehicle line, like a sedan, but it comes in several models. A basic model with standard features, a mid-level model with extra comfort options, and a premium model with advanced technology. All are sedans, but each model is slightly different to meet customer needs. From a factory's point of view, producing different models means the equipment must sometimes be adjusted or changed to fit the product. For instance, switching from making a 500 milliliter bottle model to a 1 liter bottle model may require changing molds, labels, or machine settings. This often leads to a changeover, which is the downtime between making one model and starting another.
Companies make different models for two main reasons. One, customer demand. People want choices that match their needs and budget. Two, market competition. Offering multiple models helps the company appeal to more buyers and stay competitive. In summary, a product model is a version of a product line with its features or design. Each model serves the same basic purpose, but is adapted to different customer needs.
Okay, so when you really strip this down, the entire concept anchors on this idea that a model is just a variation of a base item.
Right.
They share a basic function, but they are tweaked for different users. Let's dive into that word, variation, because to me it sounds almost like a biological term, like the variation of a plant.
Yeah, I can see that. I mean, it stems from the verb to vary, meaning to change or differ slightly from the original.
Okay.
But when you actually step onto a factory floor, managers rarely walk around talking about variations.
What do they use instead?
They use the phrase product variant.
Product variant. Got it. Or they might frame it as a custom versus standard product. Right?
Yeah.
Where the standard product is the normal item that runs on the assembly line like 80% of the time.
Yeah, the bread and butter.
Right. And then the custom variant is a special order, maybe tweaked for a specific client or a seasonal promotion.
And the brief gives us a really great framework to separate these variants by looking at their basic function versus their features and performance.
So function is just the raw, bare bones job of the item.
Right. A chair's basic function is allowing a human to sit without falling on the floor.
Fair enough.
But a feature is an added physical element, like rolling wheels or adjustable armrests. And then performance dictates how much weight that chair can actually support before the plastic snaps.
Right, which makes sense. And the text uses a car analogy to drive this home. A basic sedan functions to get you to work. But the premium model adds, a touchscreen, leather seats, advanced sensors.
All the bells and whistles.
Exactly. So from a consumer perspective, premium implies luxury and comfort. But let's say you're a listener standing on an assembly line actually building that car. Does premium just mean your physical job is harder?
Well, it means your job is significantly more complex. In factory English, premium translates to one specific, unavoidable reality.
Which is
more components.
Oh, meaning a much larger pile of physical parts just sitting at your workstation that you have to somehow attach to the product.
Exactly, and a much longer list of specifications.
Oh, specifications. That's a huge one.
It is a massive workplace word, yeah. Often shortened to just specs.
Yeah.
Specifications are the exact step-by-step engineering instructions for building that specific model.
Okay.
A standard model has standard specs. You can almost build it in your sleep once you're trained.
Right.
But a premium model has a dense book of specs because you're integrating, more wiring harnesses, delicate computer chips, extra hardware.
So the real challenge isn't necessarily lifting heavier things, it's the mental load. You have to pay absolute attention to the specs to ensure you don't accidentally put a standard part into a premium vehicle, which I imagine would ruin the entire build.
It would. And that mental load is exactly why factories use different bins, color-coded tags, digital screens at each workstation just to track the specs.
Wow.
Because if we follow the logic of the text, the product doesn't magically change from standard to premium on its own.
Right, right.
Producing different models means the heavy equipment itself must be adjusted or changed.
And adjusted sounds so light and easy, like, oh, just adjusting the rear view mirror in your car, just a quick tap with your finger.
Yeah, not quite.
Right, when a plant manager says a machine needs to be adjusted for a new model, they are talking about intense physical labor.
Oh, yeah. You hear supervisors use much heavier synonyms to describe this work. They talk about calibration.
Calibration, okay.
Yeah, that involves taking precision measuring instruments and meticulously fixing the machines so they run perfectly accurate to the new specs.
They might also call it fine-tuning, which that involves making microscopic mechanical tweaks so the production line doesn't just jam up when the new parts come down the belt.
Right.
Sometimes they group all of this labor into the phrase, setting up the line.
Exactly, setting up the line. And the brief gets highly specific about what setting up the line actually entails. It mentions that switching from a 500 milliliter bottle to a 1 liter bottle requires changing molds, labels, or machine settings.
Let's visualize the reality of a mold. Because when people hear the word mold, they often picture like a cheap plastic ice cube tray sitting in their freezer.
Right. You pour water in, it freezes, you pop the ice out.
Exactly. But on an industrial floor, it is radically different.
Completely. An industrial mold is this massive, hollow form used to shape boiling hot plastic or liquid metal under immense pressure. Yeah. So when a factory switches to a larger bottle, the operator isn't just turning a dial. They're often using a forklift or an overhead crane to unbolt a massive block of steel. The small mold pulling it out of the machine and dropping in an entirely new, massive block of steel.
That's incredible. It's kind of like baking, actually.
How so?
Well, if you switch from making, say, a bunch of small cupcakes to a large birthday cake,
Oh, yeah.
you have to change the baking pan, right? That's the mold.
That's actually a great analogy.
But in the factory, it's akin to pulling the entire engine out of your truck just because you want to use a different type of gasoline. It's a grueling, sweaty, heavy process.
It is. And all of those heavy items, the molds, the custom cutting blades, the specialized holding brackets, they all fall under the umbrella term tooling.
Tooling.
Yeah. When you swap models, you are changing the tooling.
Okay, and beyond the heavy metal tooling, the text mentions changing labels and machine settings. Changing labels, I imagine, generally happens far down the line in the packaging area.
Right, swapping out the paper stickers or the cardboard boxes.
Yeah. But machine settings, that plunges us directly into the digital side of manufacturing.
Right. Engineers refer to these settings as operating parameters.
Operating parameters.
Yes. So instead of manually turning a wrench on a steel mold, a worker is standing at a digital control panel, punching in new mathematical values for, temperature, hydraulic pressure, conveyor belt speed.
And if you enter the wrong operating parameters for the new model,
Oh, it's a nightmare.
the results are catastrophic, right? Like you might melt the plastic instead of molding it or run the belt too fast and smash the bottles together, essentially ruining an entire batch of product.
Exactly. And all that unbolting, the heavy lifting, the digital reprogramming, it forces the factory into the most critical operational state mentioned in the text.
Which is...
This is the exact moment the factory stops making products and starts burning money.
Ah, yes. The brief defines this transition as a changeover, which leads directly to downtime. And you hear managers talk about downtime Literally, the time a machine is down, like, it is a swear word. They despise it.
They really do. Because a factory is an organism designed to run continuously.
Yeah.
When the belts are moving, the company's generating revenue.
Mm.
A changeover requires a complete and total shutdown.
Wow.
Think about the physical steps involved. First, you have to purge the old raw materials out of the system. Then you have to safely lock out the electrical power so no one gets hurt.
And then the heavy lifting begins.
Right.
You pull the old tooling out, crane the new tooling in, bolt it down, punch in the new operating parameters, run a few test pieces to check the calibration, and finally restart the line.
And during that entire agonizing process, the company is still paying the hourly wages of every single worker in the building.
Oh, man.
They are paying the massive industrial utility bill to keep the lights and climate control running. They're paying the lease on the warehouse. But the machine is producing absolutely nothing to sell. It's pure overhead cost.
This is why mastering this specific vocabulary makes you incredibly valuable in a production meeting, isn't it?
Absolutely.
Like, when you confidently use the phrase doing a changeover, you're signaling to management that you understand the financial weight of the task. You understand that time is quite literally money.
Exactly. And this naturally brings up some vital opposite terms that you will hear every day. The holy grail for any factory manager is uptime.
Uptime.
Yeah. High uptime means the machines are running flawlessly, churning out models without interruption.
I love that distinction. And there is also a distinct difference between downtime and another common factory phrase, idle time.
Right. Idle time happens when a machine is perfectly functional and ready to run, but it's just waiting.
Waiting for what?
Well, maybe the raw materials are late from the supplier, or the delivery truck hasn't arrived at the loading dock yet. The machine sits idle.
But downtime caused by a changeover is highly active.
Right.
Workers are sweating, wrenching on bolts, moving equipment around.
Exactly. And that specific window of active physical labor is known as setup time.
Setup time.
So the frustrated supervisor pacing the floor might complain, our setup time on this changeover is taking way too long, and it's eating into our uptime.
Okay, but wait, if downtime bleeds the factory of money so aggressively, it begs a massive question.
Which is?
Why not just build one standard 500 milliliter bottle forever?
Yeah, right.
Like, why do companies torture themselves with complicated changeovers and massive setup times at all?
That is the big question. And the final section of our brief answers this with cold business reality. It boils down to two undeniable forces: customer demand and market competition.
Okay, let's break those down.
So customer demand simply reflects the reality that humans have widely different budgets and different desires.
Right.
One buyer wants a cheap standard bottle just to hold water. Another buyer has more disposable income, and they want, a large premium bottle with a custom grip and a specialized spout.
And if your factory aggressively protects its uptime by refusing to make the custom grip bottle, a competitor down the street will gladly buy the tooling and make it for them.
Exactly.
So market competition means fighting tooth and nail for those varied customer dollars. If you only offer one rigid model, you alienate a huge segment of potential buyers.
You really do. And on the actual factory floor, this relentless fight for the market dictates your daily and weekly schedule.
Yeah.
Management has to organize what are called production runs.
Production runs. Okay, so a production run is a dedicated assembly line is locked in to produce one single model.
Right.
And the length of that production run is determined by a critical metric called the batch size.
Exactly. The batch size is the total number of units you need to manufacture before you are forced to stop and do a changeover.
Okay, so if the sales team secures a massive global order for standard bottles, your batch size is enormous. You might run that single model for 3 weeks straight, enjoying fantastic uptime and high efficiency.
But if the sales team only sells a small promotional amount of the premium bottles, your batch size might be tiny.
Right.
It might take only 4 hours to complete the entire run.
Wow, just 4 hours. And then after those 4 short hours, you hit the wall.
Yep.
You have to shut the power down, tear the heavy metal mold out of the machine, do a full changeover, suffer the downtime, and set up the line for the next model. It sounds like an endless, exhausting cycle.
It is, but it's a strictly necessary cycle.
Mm-hmm.
By offering multiple models and suffering through the changeovers, the company captures a much wider target market.
Target market.
Yeah, that is another excellent workplace phrase. It refers to the total pool of potential buyers across all budgets and preferences.
Because without capturing that target market, sales eventually drop. And when sales drop, revenue dries up.
Right.
And when revenue dries up, the factory doors close permanently.
Exactly. So it frames the manual labor on the line in a totally different light, doesn't it?
It really does. Every time a worker uses a forklift to swap a heavy metal mold or punches new operating parameters into a digital screen, they are quite literally keeping the company alive and competitive in the global market.
And the text summarizes this reality beautifully in its conclusion, stating that each model serves the same basic purpose, but is adapted to different customer needs.
Adapted to keep the customer happy and to keep the factory open. We have covered a massive amount of ground today. As a quick wrap-up of the operational journey, we established that a model or a product variant is a specific variation of a product line.
Right.
We explored how physically switching these models requires heavy calibration, pulling tooling like massive steel molds, and meticulously updating operating parameters so the machines do not destroy the components.
And we examine how that intense physical labor creates a changeover, resulting in expensive downtime.
Yeah.
And we connected that operational pain to the ultimate business reality, meeting diverse customer demand and maintaining a sharp edge in market competition by capturing the widest target market possible.
My challenge to you, the listener, is to carry this vocabulary directly onto the floor during your next shift. When your supervisor talks about batch sizes or reading the new specs, you now know exactly how those concepts impact the company's bottom line.
Exactly.
Try integrating terms like uptime and setup time into your conversations with your team leads. It completely changes how you see the entire manufacturing operation.
Using the language of operations proves that you understand not just the physical task in front of you, but the entire business strategy behind it.
For sure. And I want to leave you with a final thought to mull over. We know that downtime is the ultimate friction point, right? It is the costly bottleneck that prevents a factory from offering infinite choices to the consumer.
Right, because of the changeover.
Exactly. But imagine a fully automated future factory where machines use artificial intelligence and advanced robotics to swap their own tooling and update their own parameters in a fraction of a second without a single human having to touch a wrench.
Oh, well, yeah.
If a factory could achieve literally zero downtime for changeovers, how wild and customized could product models become? Could every single item rolling off the assembly line be a completely unique, one-of-a-kind model built specifically for one individual person's exact specifications?
That is a wild thought.
Something to think about on your next break. Thank you so much for joining us for this deep dive into factory English. Keep listening, keep learning, and we will catch you on the next deep dive.